run. Okay? And this is what we get. I'm going to annotate verbally, okay, so you have an idea of what you should include on your printout, right, when you annotate the output. Up here, this is the syntax for running the tests of simple effects. The dependent variable is score. The independent variables or factors are sex and major. We're asking for these options. Okay, the descriptive statistics, Levine's test. This is the plot of cell means. And here are the two estimated estimated margins of means. EM means. Right here, estimated margin of means. Alright, so first, the descriptive statistics down here. This is where the data was. Okay, I put it on the desktop. You can look here. How many levels are there in sex? 2. Obviously, male and female, 16 each, so N is equal. That's why we can use the 2p. How many levels in major? 4. Okay, vocational education, physical education, English, and math, with an N of English. Okay. Here's the descriptive statistics, giving us the means, standard deviations. Not much to say there. Levine's test, which is what we use to test that assumption of homogeneity of variance, HOV. What did we want P to equal? I should say, what should we want P to be? Greater than alpha. Greater than 0.05, is it? Yes, that means the variances are the same. Okay? Or homogeneous. Okay, so that's met. Put a little note to the side about that. Okay. Here's the original two-way ANOVA. As you can see, what's the first thing we want to look at? According to our flowchart? The interaction. Here's the interaction right here. Okay, A times B. Is it less than 0.05? Yes. So we don't even look at the main effects. There's an interaction effect. Okay? We're on the bottom part of this flowchart. If this was greater than 0.05, meaning there is no statistically significant interaction effect, then we could go ahead and look at the main effects. Let's look at the main effects as if there was no interaction effect, okay, just as an example. The main effect of major, is that statistically significant? Yes. So we would need to do post hocs on those pairs, right? There's 4 majors, so each pair we would have to do a 2p on. For gender or sex, is that statistically significant? No. Okay, so all we do is state that. We fail to reject the null hypothesis for sex. Okay. Now, there is an interaction effect. Okay? So we need to do the tests of simple effects. And that's what follows here. Okay? Starting right here. And what we want to look at first are the F values. Okay, the F values are down here. Okay. Now we're looking at the effect of being a male or being a female across all the levels of major. Okay. for males, there is not a statistically significant simple effect. But for females, there is. Okay? Also notice here, the mean square and the degrees of freedom. The mean square error was taken from the overall two-way ANOVA. And instead of using the individual mean square error for each male and female, we're using the mean square error of in the original ANOVA, okay, to calculate these F values. Now, since there's a statistically significant difference in females across all 4 levels of majors, we need to go back up and look at those pairwise comparisons. We're now right here, where it says post hocs. Okay, so we need to look at those pairwise comparisons and see which majors for females are different. Okay, so we go back up here. Here are all the pairwise comparisons. Should we see any significance for males? No. And indeed, if you look right here, for all 4 majors, for males, none of those pairwise comparisons are statistically significant, which is what we saw on the UNO node. Okay, the one-way node. For females, however, down here, we do see significance. Okay, we see significance between, I'm going to call this BE and PE, BE in English, BE in math, that's 3. PE and BE, we already found that one. PE and math, that's 4. English and BE, we already found that one. English and math, no. Okay. And then math and PE, math and BE, which we already said. So there's 4. Is everyone clear on that? Do you want me to run by it one more time?
Since there is a statistically significant difference for females, we're looking across all 4 levels. So are we looking at this to determine which pairs, is it back at the pairs to?
There's an interaction effect, meaning the effect that you're seeing for females is not the same across all 4 levels.
Right.
For major are not the same for males across all 4 levels of major. That's when an interaction is. And so you're looking at, okay, what is the difference between males and females? With males, there is no difference between those groups. Whereas for females, there are differences between those 4 pairs of means.
But they might not all be significant.
No. You have to do the post hoc to figure out which ones. They could be for all the ones for female and none for the ones for male. Okay? But that's why you have to do the post hoc to differentiate which ones. Okay. So I'm going to run through that one more time. Okay?
Before you do that,
Yes.
is this like our means table, difference in means table that we drew up?
Similar, except this is just giving us the results.
It's
Yes.
a different format, but it's
Yes.
that
It's
same-
the same idea.
okay.
We're doing pairwise comparisons between, and you have to remember, we're within levels of gender. We're within females. So we're half that data table we're not even considering for the test of simple effects. And then we're looking at each cell. Okay. Same thing for males up here, but we didn't find any significance for males. Okay, so let me run through it one more time. Okay. Back up here. We run the syntax. Now, remember, when you do your homework assignment, you're going to use this syntax, which is up on the UM drive. But what are you going to have to do? Save it first, but then you're going to have to edit it, right? Because I'm specifying which variables to use in my analysis. Your variables are going to be different for the homework assignment. So you're going to have to go back and in the syntax editor, this window here, see right here? You're gonna have to go in it and change whatever variable name you have for the dependent variable and the two variable names that you have for the factors. This you can leave the same. Remember, your plot now is going to be whatever the name is for the first independent variable times the second independent variable. You're going to have to change these and change these.
How do you get to that again?
You go to File, Open, Syntax, and wherever you saved it, you pull it up, then edit it. Okay? And you may want to save it again, okay, to keep for your records for your homework assignment. After you do that, okay, after you've edited it, and remember, this is just like writing software code. Every letter is important. Okay, so if you misspell one of your variable names, you'll get an error message. Okay, so it has to be exactly like you named them in your data window, this window, these names here. Okay, so after you have this set up, you want to select all the commands you want to run, and you can either go up to run here, run all, run the selection, or use this little play button, okay, to run it again. Now, wait a second, I'm going to delete that, as if I'm doing this for the first time.
I have a question.
Yes.
The ADJ back on the other screen.
I'm sorry, say that again.
ADJ is something on the end of it. So you say that we have to copy it just like right here. The
Okay.
AD
This
what
is something
that?
I haven't talked about yet, okay? It's called a Bonferroni adjustment, okay? So with the analysis, the software is using what's called a Bonferroni adjustment in the post op.
We have to make sure we write that. That
Yes.
has to be in there, right?
Yes. All right, so then you get this output window. And with the output window, what you're going to do is print this out, right, for your homework assignment, and annotate it. And what you're going to do is explain everything that's in the output. And it's pretty simple, right? You're just talking about what this is. Well, this is the